Okay, so last week we did talk about all of our operations with whole numbers, decimals, fractions, integers, the negatives, and all that. Today we're going to start with what we didn't have time for last week, and that's what happens when we run into a problem like this. When we see a problem like that, it's really tempting to just start on the left and work our way to the right, just like reading a book. Excuse me. You might look at it and do, well, 4 plus 8 is 12. 12 times 2 is 24, and then plus 7 is 31. And that makes perfect sense, only that's not the right answer. To guarantee that two people look at a problem like this and get the same answer, we've defined something called the order of operations. A lot of people describe the order of operations as being steps, and that can be a little confusing. The easier way to understand it is to think of it as levels of priority. You guys are in the medical field, so you might understand the whole idea of, precedence of if it's a critical or if it can wait or whatever. You put it in priority, and certain things have to happen right now. Other things can wait till later. And that's kind of what the order of operations does. It defines the number one, or first level of priority, something called enclosing symbols. Many of you have probably just heard this one called parentheses. Parentheses are a form of enclosing symbol, but they're not the only one. We'll see a couple others here before we're done. The second level of priority is then exponents. Exponents include two things: powers and roots. So that's our second level of priority. Third level of priority is multiplication. Now remember, we said that multiplication and division are really the same operation, just one's forward and one's reverse. So this also includes division here. Our fourth level of priority, our final level of priority, would be addition. And of course, with addition is included subtraction. So if we look back at this problem up here, there are no enclosing symbols, so there's no level 1 items we need to do. No exponents, no powers or roots. So we're down to level 3 before we hit something we have to do. That's multiplication. That would be the 8 times 2. So let me rewrite this problem down here. So what that's telling us to do is we're going to do that multiplication where we combine the 8 and the 2 and we replace it with a single number, which in this case will be 16. And then the rest of the problem stays unchanged. Now with this problem, the only thing that's left is a couple of additions. So that's the only thing we have on our list. There are 2 additions to figure out what to do first. Now we work left to right. Everything is on the same level of priority, you go left to right. So 4 and 16 make 20, plus 7 is 27. So that would be our correct answer. Well, let's look at one that's just a little bit more complicated than that. Something like this. Now, if we look at this one here, first level of priority is enclosing symbols. We have those here. We have parentheses. So here's the first parentheses. There's its partner over there. There's its mate. So what those enclosing symbols do is they narrow our focus. So now we're only looking at a specific portion of the problem. In this case, we're looking at that blue box. So now inside that blue box, we still have to do our order of operations. Are there any other enclosing symbols in there? No, there are not. The next step then would be exponents. Are there any exponents there? Yes, the square root of 4, which would be 2. So we replace the square root of 4 with 2. The rest of the problem stays unchanged. Now we have a 3 here in front of that square root of 4. There's an operation implied there, which is multiplication. That's 3 times the square root of 4. Next, we're still working inside the parentheses. Are there any other exponents? Nope, that's it. So the next step would be multiplication or division. We have 2 multiplications. We work left to right. So 3 times 2 comes first. That's 6. And notice I just take out the 3 times 2 and I replace it with the 6. Everything else stays unchanged. Next then would be the 3 times 4, which is 12. Now we've done all the multiplications and divisions we can do. We're down to level 4, which is addition and subtraction. There's both there, so we're going to go left to right. 7 minus 6 is 1. And then 1 plus 12 is 13. Now that we've reduced what's inside that enclosing symbol, in this case inside the parentheses, to a single number, we don't need the parentheses anymore. So I can take that parentheses out. Now just like the square root, we have this 2 in front of the parentheses with no symbol there. That means we have to put in multiplication. That's 2 times what was in the parentheses. So that'll be 2 times 13 now. Minus 1. Now that we've completed the parentheses, we have to go back through the levels again. Any other enclosing symbols? No. Exponents? No. Multiplication or division? 2 times 13 is 26. What would be next? Addition and subtraction. We're going to go left to right. 8 plus 26 is 34. Minus 1 is 33. Now, technically, when I do these, you should rewrite the whole problem every time like I just did, taking one number or 1 or 2 numbers and replacing them with a single number that you put them together. I've found through the years that a lot of mistakes get made not in doing the operation, but in rewriting the rest of the problem, like that. So I'm going to show you what I do. It might help a little bit on your paper. Instead of rewriting it every time, you can erase and rewrite some of the times. I'm going to do a little bit more complicated example, and I'll show you what I do just because I'd be writing for 3 pages if I wanted to rewrite it every step. There, just a little bit more complicated. Now, in a problem like this, I'm going to rewrite the whole thing once. So we'll do the first step and we'll rewrite it once there. And then I'll show you what I do from there. So we start out enclosing symbols. Well, there are several sets of parentheses here. When there's more than one thing on the same level, remember we worked left to right. So going left to right, here is our first parenthesis. So we're going to start with that. Now we need to find its other end. Is this one it? No, it faces the wrong way. How about this one? Nope, faces the right way, but it goes to that other one. This one here is the other end of it. So we're going to start our work inside that set of parentheses there that makes the blue box. Now some of you might be thinking, but we got to start inside. Yeah, we do. Inside this set of parentheses, inside this blue box, our order of operations still applies. So we're still looking for level 1. Are there any other enclosing symbols? Yes, there are. There's another set of parentheses right here. So now we have to start inside that set of parentheses, or inside the red box for now. In there, are there any other enclosing symbols? No. Exponents? No. Multiplication and division? Yes, we have 3 times 2. So I'm going to replace the 3 times 2 with a 6, and I'm going to rewrite the rest of the problem. Now what I'm going to do is, rather than rewriting the whole problem every time, I'm going to erase and replace the numbers a little bit. I know in your notes that makes it tough, so I will go slow for you. So if you want to rewrite the whole thing every time, you can. Otherwise, if you just want to follow along, you can always come back and look at the recording later and get all the steps off of that. So anyway, we're still working inside this set of parentheses here. There's only one thing left to do, which is add. 2 plus 6 makes 8. Well, now that we've reduced that parentheses to a single number, I can get rid of the parentheses. Now before, when we took out the parentheses, we had to put in multiplication. Do we have to do that here? No, there's an operation in front and behind the parentheses, so there's no need to put in multiplication. Well, now that we've done that, we're back out to this bigger set of parentheses. What needs to be done first there? Exponents. 2 to the 3rd power makes 9. Oh, sorry, 3 to the 2nd power, I'm sorry. Makes 9. Now there's no more exponents. We're down to doing multiplication and division. We have one of each. We're going to work left to right. 4 times 9 is 36. So we take out the 4 times 9, replace it with 36. The rest of the problem will stay unchanged. Next, we divide. 36 divided by 12 is 3. So now all that's left is addition and subtraction. We're going to work left to right. 18 plus 7 makes 25. Next, we have the 25 minus 8 makes 17. And then we have 17 plus 3, which is 20. And as I said, after a few steps, I usually rewrite the problem just because everything gets too spread out if I don't. So now we've replaced everything inside that parentheses. It's been reduced down to a single number. So I can get rid of that set of parentheses if I want to here. So I take out the parentheses. This time, however, I do have to remember to put in multiplication because there was no symbol between the 3 and the parentheses. Well, what's next? We have another parentheses here, another enclosing symbol. Inside there, are there any other enclosing symbols? Not really, but we have the exponents. The square root of 9, which is 3. And then 8 minus 3 makes 5. And now we've reduced what's inside that set of parentheses to a single number. So we don't need that set of parentheses anymore. And when I go to take them out, I see that there is an operation in front of those parentheses, so we don't need to put in multiplication there. So now we're done with that set of parentheses. We're starting over again with the whole problem. Any other enclosing symbols? No. Exponents? No. Multiplication, division? Yeah. 3 times 20 makes 60. Now it's just addition. 9 plus 60 is 69, plus 5 is 74. Not so bad? Okay, next. Remember one of those mornings where the brain just doesn't want to quite kick into full gear? Let's see, where am I at? Let's see what that does. What's the worst that can happen? Okay, something like this. To understand a problem like this, we have to understand this symbol right here, this line across here. What's that telling us? What's that mean? It does mean division. It's called a fraction bar, and it does mean we're going to divide. But it's also an enclosing symbol. It separates the top of the problem from the bottom. It tells us we're going to do each of those parts separately. We're going to do all of the top, everything on top. We're going to do everything on bottom. Then we're going to divide them. So we're going to start out doing the top of this one. So on top we have 9 times 7 minus 45 divided by 3. What do we have to do there first? 9 times 7 is 63. And then divide. 45 divided by 3 is 15. And finally, 63 minus 15 is 48. So that's the top. Now we're going to do the bottom. On bottom, what do we have to do first? Exponent. 5 squared is 10. What's next? Multiply which one? Left to right. 9 times 8 is 72. And then 5 times 2. Then what? Left to right, we're going to do a subtraction. 72 minus 10 is 62. 62 minus 10 is 52. 52 minus 1 is 51. So we have 48 over 51. Now, we could divide this out and get really ugly decimal. Or, remember we discussed a little bit last week how fractions and division problems are kind of interchangeable. Instead of thinking of this as 48 divided by 51, we can think of it as 48 over 51 as a fraction. And just reduce it. Both of those numbers can be divided by 3, which gives us 16/17. Have any of you played around with the fraction button on your calculator? Okay. Many of your calculators have a button. It looks like this, ABC. If you have a Casio, it might be something like this. It just has like blank boxes there. You can enter something like 48 over 51. Instead of entering it as division, you can type in 48, press that ABC button, and put in 51, and hit equals, and it'll automatically reduce it for you to 16/17. You can also use that for doing your operations with fractions, but I'll let you play with that on your own. If you have any questions, let me know, and I'll help you with it. That calculator does do remarkable things. For most of it, you can. The first half of this first test, you can't use the calculator. A lot of it's on the first half, unfortunately. Like I said, though, remember, once you're done with the test and once it's graded, you can go back and redo things. And you can use your calculator and stuff when you do corrections. Let's see, one more type of problem I want to show you, then we'll move on from the order of operations. Looking at this, we see the square root symbol. But in this case, that square root symbol is also acting as something else. It's also an enclosing symbol because it is separating this part of the problem from the rest. So we have to work inside that square root symbol first. So inside there, do we have any other enclosing symbols? No. Exponents? No. Multiplication or division? Yes, we do. 9 times 7 makes 63. And now all that's left inside there is the 1 plus 63, which makes 64. Now, just like any other enclosing symbol, once we've reduced what's inside of it to a single number, we can get rid of the enclosing symbol. Unlike the parentheses, however, where the parentheses we could just remove them and we didn't need them anymore, this square root symbol is actually called the radical symbol, is its official name. When we remove that, we have to do something. There's an operation we're being asked to do. So we remove that square root symbol. We have to do the square root of 64, which is 8. And now there was a 2 in front here with no operation. We do have to put in multiplication. Now, there's no more enclosing symbols, no more exponents. We are down to multiplication and division. 2 times 8 is 16. 8 plus 16 is 24. What do you think? Not as scary as it could be? Okay, well, to finish off our first hour of class here, we're going to talk about Roman numerals. We used to learn a lot about Roman numerals. It's kind of faded in recent years. The medical field is one of the few fields that still use it. The other one that uses it heavily is publishing, still uses Roman numerals. If you ever look at the copyright page of a book, you'll see, X, M, M, C, whatever. That's actually the year of publication of the book. So what Roman numerals are is it's what the Romans used to use, different symbols that they used for representing numbers. Part of it was the concept of a zero hadn't really been created yet, and the whole organized place value system wasn't created, so they just had symbols that stood for certain amounts, and they combined those symbols to make larger amounts. For example, 1, or what we would consider to be 1, just used the symbol I. I was always taught that Roman numerals were capital letters, but now in recent years it's become acceptable to use small letters. So even though I put down a capital I, it could be a small I that's used as well. If we get up to 5 items, they use V to represent that. $10 is represented by an X. 50 is represented by an L. 100 is represented by a C. Anybody ever hear a $100 bill referred to as a C note? That's why. 500, we use D. 1,000 uses the symbol M. And then one that's not used outside of medicine very much, but it's actually very popular in medicine, is SS. And the two S's have to be together. They stand for a single number. That's 1/2. So in the Roman numbering system, and the reason it's used in medicine is the Roman system was very, very tightly tied to the Latin system. All your medical names and terminologies are very much based in Latin. So that's why it kind of got pulled into medicine. But anyway, in the Roman system, to make numbers, you just combine symbols. For example, to make the number 7, you start out by taking the largest possible symbol. Well, the largest of these values here that we can take out of 7 would be a 5. So that's a V, that's a 5, and then you would add 2 1s to that to create a 7. So VII creates a 7. Sometimes you'll see them like that, but you don't necessarily have to. So 3 is just going to be I. 3 1s added together. However, one of the quirks of Roman numbers, at some point they decided they didn't like having three symbols in a row that were the same, or more than 3 symbols in a row that were the same symbol. So to create the number 4, rather than doing 3 or 4 I's, they thought that took too much paper, or too much space, I should say. So what they did was this. They would take a 5, and if you put a smaller symbol in front of a larger symbol, that's subtracting. So VI, since the larger symbol is first, the 5 is before the 1, you're adding those together to get 6. IV, since the smaller symbol is first, it's 1 before 5, that's subtracting, that represents a 4. That way they avoid having more than 3 of the same symbol consecutively to create a number. So anything that's a 4 or a 9, you're going to deal with that. For example, 9 would be written not as 5 plus 4 1s, but it'll be written as a 10 minus 1. So you have the X, then the I is put in front of it. Here's one that was always confusing to me. They tend to only subtract 1s, 10s, 100s, or 1000s. They don't subtract 5s, 50s, or 500s. So to make 47, to me it would make sense to take 50 minus 5 and then add 2 to it. They don't do that. They take their 50, which is their L, and they subtract 10 from it. That takes it down to 40. Now we have to add the 7. So a 5 and 2 1s. So if you're reading what's happened there, the XL is 40. That's 50 minus 10. Plus 5 plus 1 plus 1. So something like this, 2,943. Well, we're going to do the 2,000 first. That's M and M. 900. Well, we could do 500 plus 4 100s, but again, then we'd have 4 100s in a row. So what we're going to have to do is take 1,000 and subtract 100 from it. So again, this is 1,000. This is another 1,000. Whenever you have a smaller symbol in front of a larger one, they have to combine. That's 1,000 minus 100, which is 900. So we're now at 2,900. We need to add the 43. The 4 is going to be, well, 50 minus 10. So L minus X. So there's 40, and then plus the 3 1s. That takes a little bit of getting used to. Or if we have, say you've got an order for 8.5 grains, how would that be expressed in Roman numerals? Well, the 8 would be what? 5 and 3 ones, right? VIII SS for 1/2. Usually smaller. The S's are always written in lowercase. Like I said, now it's acceptable to write all your Roman numerals in lowercase, which is not what I was taught. But so now you would see that expressed as VIIISS. It might not be uncommon to see that. Probably more important for you guys is to be able to convert the other direction. If you're given a Roman numeral, to be able to put it into a standard numeral, into a decimal number. For example, what would that stand for? Yeah, IV is a smaller symbol in front of a larger one, so that's 5 minus 1 is 4, and SS is 1/2. Let's look at this one. CD, what's that stand for? 400. That's 500 minus 100 is 400. Now, do we read the X as a 10? No, because it's a smaller symbol in front of a larger one, so we have to read the XL together. 50 minus 10 makes 40. And then VI. Do we read that as, is that 5 minus 1? No, it's 5 plus 1, which would be 6. That's 446. So on this one, we start up here. We have an M. Is the symbol after it larger than it? No. So we just read that M, which is 1,000. Now we have the C. Is the symbol after it larger than it is? Yes, it is. So we've got to read the C and the M together. 1,000 minus 100 is 900. Now we have the L. Is the symbol after it larger? No. So we can just read the L, which is 50. X, is the symbol after it larger? No, but it's the same, so let's combine them. So we have an X and an X, that's 10 and 10 makes 20. Now we have the I, and of course the symbol after it is larger. So IX means 10 minus 1, or 9. So it's 1,950 and 20 is 79. Any questions? So if you have an order that calls for ISS grains of medication, what's that stand for? 1 1/2. Perfect. Okay, it's a touch early, but this is a natural break in our material for today. Let's take our break right now. We'll come back about 9:20.